Hello everyone and welcome to our new video. In this video, we are going to discuss about the Terraform variables. This is basically the part 2 where we have already gone through the basics of the Terraform. If you have not gone through that video, I will suggest you to go through that video because it covers a lot of details about the Terraform and the best practices and how to get started with the Terraform. This is the second video, and where we are again going to cover the programming aspect of the Terraform, and we are going to understand basically how we can use the variables, what is input variable, output variable, local variables, because when you start writing the Terraform configuration, you will be needing all of this to make the generic configuration and modules which you can actually use to provision your infrastructure within the different clouds like your AWS, Microsoft Azure, and different cloud providers out there. So we are going to discuss in more detail, and this same will be our agenda where we are going to cover about the Terraform variables, one of the most used resource. Then we are going to discuss about the input variables, how you can get the output of the resource which are created, basically the DNS endpoints, etc. Then we are going to cover about the local variables, how you can pass on your own variables and the conditions in that. Then we are going to discuss about the conditioning within the Terraform, how you can iterate and use the loops. Then we are going to discuss about the various resources, metadata. Then we are going to discuss about data source in Terraform, which basically allows you to query the resources using the API, which will fetch back you the data from their APIs, which can be used inside with your Terraform code that you have written. Then we are going to discuss about the operators in Terraform and interpolation of the text. So all of this plays a very crucial role, and you should be aware about each of these in detail because this is what you will be finding within the configuration. This is going to help you in order to understand the configuration which you are about to run and make the changes with the help of Terraform into your cloud providers. All right, so let's get started. So first of all, we are going to start with the Terraform variables, which allows us to create the dynamic variables. Now, if you are finding the speed a bit too fast, I will suggest you to change the speed to a slower, or if you like 0.75x or 0.50x, that will slow down. But this is the normal pace at which I will be covering this, so you can adjust it according to your requirement. So let's get started with the Terraform variables. Now, if you see, the variable is basically something which is going to hold your value. So you can assign variable a value. Now, the advantage here is that whenever you are going to create a variable and assign it a value, okay, that value can change, right? So you don't have to change your configuration every time. You can actually use your variable, and these variables can be changed. Now, suppose you have a resource, let's say you are creating an instance. Now, different teams are going to name that the EC2 instance, let's consider that example differently, right? So each application will have a separate name, and you want to associate that name inside the tags. So rather than hard coding it inside your configuration, you can actually use the variables in that case. Now, when you are going to use the variables, its value can change. So basically, each team can set up the variables according to their own requirement. This will help make your configuration reusable so that different teams are able to use the same code and you don't have to copy it again and again. So this will actually remove the duplicacy. At the same time, same code can be used by multiple teams. Think of this more like a framework which the different teams are bound to use. At the same time, the code itself is not getting changed. So every time you see the servers, you are going to feel it, they are treated exactly the same way, just that the name appears to be different. This is why variables become so important. Now, the information in the Terraform variables are saved independently from the deployment plan. So it is not dependent upon it, but whenever you are going to run the plan, it's going to show you those values, which becomes easier to read and understand. and you can edit it from a single file as well. So you can actually group all the variables inside the variables.tf file, and this will help you understand basically what all values you can change within a module or the configuration that you have written. This allows you to have a greater control and easier way to understand, and it shows you the overall picture, so it becomes and change the. Another example can be easy to instances, but at the same time, you're depending upon your CPU and the memory requirement. You don't have to rewrite entire, makes the code reusable. Now, if there are basically three types of variables, this is, and it can variables that you have input into the tables are the ones when you endpoint. Let's say you require the DNS endpoint for that load balancer in order to make a request to that load balancer. So output variables can provide you the output so that you don't have to log in to your AWS dashboard and get that value. Obviously, you can get from there, but obviously it would be much slower because now you are applying the Terraform changes. So it will provide you an output. You can make a request and directly confirm it. The other example can be, let's say, EC2 instance IP, right? So whenever you create an EC2 instance, you might require the instance IP to do SSH inside a server. So in those cases, again, the output values make sense that it should be provided at the very end, so that the person who has applied the changes is able to get that the instance has been successfully created and the output is available, which it has to use even further. Last one is the local values. You can pass your local values yourself. So if that is something, which AWS is not providing, you might have to pass a team name, or you might want to pass your own configuration. Then you can again configure that as a local value and use it inside the configuration. We are going to see this in more detail with the examples in the slide ahead. Next is, now here you can pass the variables in different ways. That is, you can pass it within the command line. But now when you pass it within the command line, you can actually run Terraform, apply and pass the variables. If you do it that way and you are passing a variable within the command line, that is going to have the maximum precedence. What this means is that if suppose I have created a variables.tf file, but if I pass it in my command line, then the Terraform will be picking up the ones which I executed in my command line rather than the picking it from variables.tf file. Next comes your auto.tf wars. Now this is actually this is dedicated Terraform files just for assigning the value. So this is holding the preference over the other Terraform ways of assigning the variables. Then comes your Terraform tf wars JSON. Now because you have added the JSON, it's basically the key value pair, so it will be holding a precedence over the other variables types that you are going to insert. Now next comes Terraform tf wars. This is where you are going to insert, generally this is the way that we create the variables within the Terraform. So it will come at the fourth level. Then comes your environment variables. Now you set up the environment variables because you might have to pass some configurations which you might not be able to directly pass inside your version control system. So it makes sense that you pass it as an environment variable. It will hold a preference over the variables.tf file, and then comes your variable.tf, which has the least of the precedence. What this means is that the way this works is like the command line is going to have maximum precedence, then comes auto.tf vars, then comes Terraform tf vars.json, Terraform tf vars, environment variables, and variables.tf. So sometimes what happens is whenever you are executing the code, you might find that you have a variables.tf file and there is a variable value which is getting passed, but when you are applying the changes, it is coming out to be exactly different. Now you might get confused in those ways, what is happening and why the actual values are not being picked. In these cases, the variables precedence you have to remember, because it might be picking from the tf wars, because of which the variables.tf might not be there, or it might be some environment variables has been set due to which it is getting overridden. So again, depending upon the precedence, this becomes very important, especially when you are troubleshooting and you are finding that some of the values might not be as you expect the Terraform to pick it up. In those cases, you have to go through the precedence and remember it. Next is Terraform is interactive. Terraform asks you for the values not otherwise provided. What this means is, suppose you create a configuration and now you define a variable. right? So every time you create a resource, you can define a variable. Let's say I define a variable and I put a variable there. Now it is possible that I might not use the variable in my configuration, but because I created this variable, and Terraform will see that there is a variable. Now you didn't provide it by default, so every time you run, Terraform is going to ask you for that variable. This is known as interactive variables. So you can pass it at the runtime. Now, but whenever you are going to create a CI/CD pipeline, at that time it might become obstructive. That is, what we expect from the CI/CD pipelines is that it is completely automated and we are not going to pass any manual values. But if Terraform is going to ask you interactively for a value, then it doesn't hold much about the CI/CD pipelines. In that case, what you can do is you can actually pass a default value, and default values always start with a minimum value. So suppose, let's say I create a auto scaling and I have to pass the minimum number of instances. Now, usually I can configure a variable there so that the people are able to define the minimum number of instances inside the auto scaling according to their own requirement. But at times you will find that this sometimes they might not actually define the variable value, and then when they try to run the CI/CD pipeline, it might ask you interactively for inserting a value, which might break sometimes the deployment, and people might not be comfortable with it. In those cases, how we handle is that we pass what is a default value, right? Now, what is a default value is can be 1. So if someone doesn't pass the value, or they didn't created a variable and didn't put updated the value over there, so we can pass a default value. Then what Terraform is going to do is, if even the person didn't pass any value, it will going to take the default value. So it will not ask you interactively, it will automatically pick up the default value and run ahead. Next is module invocation. So you can actually invoke a module and provide the opportunity to assign the value. So again, modules can be called directly within the Terraform. Usually there are 2 types of modules which have been created. One is created by Terraform, which you can directly call from the Terraform registry, and those modules you can use. These are basically the publicly available modules which has been created by Terraform. It has a lot of parameters. You will have to refer to the Terraform documentation and configure those parameters according to your own requirement. Then sometimes what happens is that you might not be comfortable with using the modules which are publicly available because they are for separate resource type. Let's say you are using ECS or EKS. In those cases, what happens is, let's say you are calling the secrets manager, you are creating parameters, you have to create IAM roles for calling the different resources. Now, what happens is in these cases, you can actually write your own modules, and this allows you to create a framework which your teams can inherit. Now, they might not be entirely aware about it, but once you provision and write a Terraform for it, this becomes a larger practice. They will actually have to cater to those requirements in order to use the ECS. This is how you can guarantee that the process that you have laid out in your organization is followed by each and every team. And this is how the module invocation works differently. We are going to discuss more about it in the slides ahead. Next is, so this is how the precedence works. And we already discussed about the command line auto TF wars and how you can actually pass the different ways of the variables inside the Terraform itself. Now, after this comes your Terraform input variables. Now, input variables are very important because we are going to use it extensively whenever we are going to do the lab session, and we are going to pass a lot of input variables over there. So if you look at the input variables basically serves as a parameters for the Terraform module. So what you do is you write this input variables which the Terraform expect, and this makes your module more customized in the way that anyone can change the values according to their own configuration. So normally how it works in organizations is that you can create a module in a centralized repository, and you can fork those repositories, and then you can pass it across your own variables within your own repository. So what this will allow you to do is that each team can fork the modules. You can keep it at a centralized place, and they can pass their own variables. This will allow the different teams to reuse the code. At the same time, they will be able to run the Terraform with the same piece of code. So as in DevOps or an SRE engineer, it will make it more easier to guarantee that the overall process is not breaking up, even though the developers might themselves be doing it, or there might be SRE people who are actually picking up and just poking it and creating these applications infrastructure for them. But then again, this is going to guarantee that the overall workflow that you have created is being followed across everywhere. Now, when you declare a variable in the root module of your configuration, you can set their values using the CLI options. Now, this means that whenever you are actually passing it, you can pass the variables directly inside your Terraform apply command, and this holds the highest precedence. What this means is that it is possible that same variable might already be used inside the configuration, but when you put the variable inside your CLI, then it is holding the maximum precedence, so it will always be applied. The variable with value that you have passed will be picked up first. So this is how you can do it. Also, you can set up the environment variables if you don't want to visible. Let's say you are executing and you don't want to put it in the command line because of the multiple security issues that might be from the secrets perspective, then you can actually pass it inside the environment variables as well. And when you declare them in the child modules, the calling module should pass it as a module block. So again, this is how you are going to call the input modules. Now, what happens is normally Terraform can actually pick up the values for your variables, but it is always good to put your variables type. That is, Terraform is going to support the different types of variables. Like you can pass it as a string, you can pass it as a number, list, which we commonly use. So, and map is like something of a key value pair. So suppose if you have multiple key value pairs and you want to pass it like that, you will have to put the map value over there. Then comes Boolean values, true or false, and set, object, and tuple. So all of these values are supported by the Terraform input variables. You can actually define this variable types. Now, why you should define it when Terraform is able to pick it? The answer here lies in the fact that if you define a variable and suppose someone is trying to put a different value to it, let's say you said number and someone is trying to put a string or trying to put a Boolean value or something like that, then Terraform will give it an error and they will be able to pretty much able to understand that, you know, this is the issue, that they have not passed the correct value. So it acts like a validator of the values that you have been passing. So it makes it more easier that you have a validation in place so that the variable values are correct and Terraform is able to perform the resources, update the resources accordingly. Okay. Now, if we talk about the input variable, okay, so this is going to hold a certain types of values. So what you can do is you can always define a default value. This I explained you earlier. Every time you create a variable and you are actually going to integrate it in your CI/CD pipeline, try to assign a default value to a variable, and it should be the least value that you assign. This will allow you to seamlessly work. If a person forgets to insert it, then also the resources will be moving ahead and the CI/CD pipeline will be working fine. Obviously, when they review and they check the resources, it will be less in the number. They will understand that, you know, the default value was picked up and they can always override and apply the changes again, which will increase the value. So this is how you apply the default values. Then comes the type. I already discussed about the types right now, where I discussed the various types which are supported by the Terraform. Now, you should always define the types. It acts like a validator. Next comes description. Description is for your understanding. This is not something which is used by Terraform. This will increase the readability of your Terraform code that you have written, and this will allow the others to understand basically why you are doing, what changes you are doing with the Terraform configuration. Next comes validation. So validation is, it allows you to validate the rules, usually in addition to the constraints. So you can put certain types of constraints when you are defining the configuration, and validation is going to verify that, you know, those validation rules are applied and the configuration is created according to your requirement. Next comes sensitive. Now, sensitive is basically that Terraform is going to restrict certain types of output. It might be your secrets, which you don't want to reveal while applying the changes. So that is where the sensitive values comes, and you can actually make it sensitive so that the people who might have access to the UI are not able to directly access the values. This increases the security, and always a good practice if you are dealing with some kind of secrets within your configuration. Now, let's take a look at example here. So suppose here, if you see, we are creating a variable with a CIDR block. So what we are doing here is we have created a VPC CIDR block. This assigns the range to the VPC that the virtual private cloud, the inside your from which the entire IP address will be picked up, right? So you can create a variable for it. Now, what this is important because suppose if this variable, if someone is using this configuration across multiple teams or verticals, then it becomes necessary that the value of the CIDR block should not overlap. This is important because if two verticals application need to talk to each other tomorrow, then they should be unique. Otherwise, you won't be able to peer them up or insert them in the transit gateway, and they cannot communicate with each other. So it makes it is very important that they are different. And usually for this case, you will find that the CIDR blocks are separately stored and managed in every organization so that the overlapping of the CIDR blocks are not there. And these variables are defined separately. So if you are creating this VPC CIDR block, each team can pick up their own CIDR block, and this is how you guarantee so that it makes it repeatable and multiple teams are able to use it. Now let's look at the type number. So here you can find that this is a piece of code which you actually start with. So we always put this inside a providers.tf file. This actually updates the Terraform, which type of provider, basically which cloud provider you are using. In this case, we are actually using the AWS. So this helps in Terraform identify the resources. So remember, this is the very first point of starting with the Terraform. You are going to define your cloud provider, you are going to define the region in which you are working. Now, access key and secret key, obviously these are not that much secure way, but when you are actually starting initially, you can use this process. What this is going to do is that it's going to allow you to connect to and authorize to the cloud provider, but this is not generally a good practice. The reason is that this access key and secret key, if you commit it inside your configuration management tools, other people can access it. This can lead to compromise of your AWS account. So generally this practice is not good in the production environment, but when you are initially starting and learning the Terraform, at that time it is particularly fine. You can move ahead with the access key and secret key definitions like this. Now here, if you see, we are defining the number of users and the type here is number. Now we can actually, so this is basically for the number variable, and default value is set to 3. So that is, this 3 is a number you will find. If you try to insert let's say 3 in a string form, then it will give you an error. So this is how the type matters, and this is a good practice that you should always associate a type with your variable. This is going to help you assign the variables the value, and it is also going to act like a validator for that purpose. Now every time you are working with the Terraform, you are going to manipulate the resources. This is the most important thing. So you will have to identify the resources which you want to manipulate. It always starts with the provider name. So you can see AWS is the provider and IAM user is the resource which we want to manipulate, right? So this is the resource that we wanted to manipulate. Suppose if we wanted to manipulate security group, so instead of IAM user, we will write AWS underscore security underscore group like that. And then we put a name, like here it has put the example of the resource for the IAM user, so we can associate with it. Now if you see, we are actually counting here we have passed a variable, like it says variable number of users. Now moving ahead with the Terraform latest version, now this is something which was actually followed in the older version of the Terraform, where you used to define like this. And within the newer version, you are just going to define variable and number of users. So string interpolation is no longer required. You can remove this curly brace. So this is no longer required. You can just put a dollar question dollar and you can directly put this value. This is going to work absolutely fine. This is a change which has been introduced from a older version of Terraform to the newer version of Terraform. So you have to remain updated with the changes. This is sometimes happen with all the tools out there right now in DevOps, that these tools gets updated. So you have to be sure that you are always following the latest syntax which these tools are supporting. This is actually makes it more of a learning curve that you have to keep updated, and this is what we call as erosion, that over a period of time. Next is name. Okay, it is actually going to call this, and it's picking up it's going to resolve to 3, and it's going to assign the and put a number that is 3. So this is how you can enable inside your resource definition to the next type, that is basically a not only limited to the clouds. Like if you see here, we are there, and instead of directly example of GitHub, right now you can, next is organization name. You can define any name that we are actually defining a repo here. We have defined as string. I've defined the string variables. Now it's as day3 broad. Now what repository doesn't set up these environment variables, right? But if it doesn't, part manipulating the GitHub repository repo name, this allows the different teams to allow them to reuse this which will help you parameter that you are passing inside your, so it says false. Let's move ahead. Now, if you see here, we are going to define a type of a list. So here is a list. You can actually define various types of lists over here. Okay, so it shows you the list here shows you can actually define the different 11 file and file 30. So what is happening? I'm having multiple values to be assigned, right? It's particularly helpful in a choice between the instance type that you can select. So you can assign a particular type of instances and any one type of instance. Here you will find that we are working with the Git repos. So you can actually define the list and create a list of the variables that they can pick from. And if you see here, we have defined the 3 different types of resources which we want to manipulate, and eventually we are actually using to create the users and creating the Git repositories and assigning the repo names within it. Now here, if you see, we are the first of the list variable. We are calling it the index here. And if we are creating a user, again, you don't need to use this curly braces in the latest version. Okay, it will work particularly fine without it as well. Now, always a list starts with a 0th element, then it goes with 1, 2, like that, right? So you will find that if I just wanted to insert the first value, I have called inside the square brackets a 0, so it will pick this value 1, that is file 11, and similarly in the second one, it will pick the second value, that is file 12, and so on. So it can you can actually pick the elements from your list separately using the list type, and you can pick the values from it. Here is another example of users, like we have passed a root, user1, user2. So if you say we can pick any of the user. If we are calling the user 0, then it's going to pick the root user in this particular case, like that. So you can use the list accordingly. Then after that comes your map value. So here you can see map, it basically works in a key value pair. So if you see, we have defined a value called plans, and we have defined a map here, and we are creating the default values as this is a key, this is a value, right? So we have said 5 USD equal to 1 into CPU 1 GB, 10 USD equal to 1 CPU into 2 GB, 20 USD. So you are actually mapping it with the price, so that you are able to determine and able to execute and call these values. So now if you see, whenever we are assigning a plan a value, we are basically calling the plan, and we have to pick the 5 USD, which will automatically resolve to 1 into CPU equal to 1 GB. So this value will be actually executed. You can define the maps according to your requirement, okay, of the variable. Now next is, if you see, here is one more example for you. So here, if you see, we are defining the different AMI. So we created a map here so that it becomes easier for us to identify in which region these AMI belongs to. Suppose it belongs, now you can only use the AMIs in a particular region, or you will have to copy that AMI into another region within your account before you actually use it. So Here, if you see, we are using the AMI, this one in US East one. So we have defined it under the default like that. And US West 2, we have picked the second AMI. And similarly, you can create a map. Now, suppose whenever you are going to create an instance and whenever you have to define an AMI, you can actually define the variable of AMI. So it will pick this value from the AMIs. Okay. And then we have defined the variable dot region. So if we put a region, suppose I put AMIs dot, it will come like this, AMI, and inside the region, suppose US East 1. So Terraform will be able to deduct that we are actually calling this AMI. So Terraform will automatically resolve to this value, right? So this is how you can actually use the map value and it makes your code more readable. Similarly, if you see here, we are defining the account name. We are actually putting account 1 as DevOps 1, account 2 DevOps 2, account 3 DevOps 3. And whenever we are going to create the IAM user, we can actually, for each account type, we can actually create a user. And here you are seeing that we are using a for loop and we are able to resolve it from the map type of the value, right, for the variable. So we can pick up from the map. Here are the two distinct examples. So these examples will help you better correlate with the variables, and this will help you to even use it much better way when you are going to write the configuration. Now, after the map comes your bool values. Now, bool values usually is for setting true or false. Only two of the type values are permitted. So if you see here, we are setting up a variable called set password and default value is set to false. Now what will happen is every time you are using it, let's say create password variable set password, so it will automatically assign it a value of false. And you can always override the values by putting it in the command line, so it will always override those values. Okay, so now here is another example where we create VM and we have set the values to bool, and again create VMs and set the value to bool. Now what happens is, let's say we are raising a Azure virtual machine, so we can actually count the variable. So we can actually put like this. So suppose if a variable is set to 1, okay, or 0, right? So what's going to happen is, if it's true, it's set to 1. If it's 0, it's true is set to 0 and false is set to 1. So depending upon what variable you have defined, if it finds it, it will create the VM, otherwise not. So this is also a way to manipulate when you want a resource to be picked up. This is what you can actually use inside your configuration as well. So next is output variable. So let's go through the Terraform output variable. Now Terraform output variable allows you to output the resource type. So suppose if you are creating an EC2 instance, you want the IP, then you can define the output variable and it's going to give you an output. Now output variables allows you to organize the data, which can be easily queried and shown to the Terraform user. And Terraform can store thousands of attributes in your resources, which is more likely to be interested in few values of important. Here are some of them. So suppose if you create a load balancer, you can print the output of the load balancer, or you can always print the IP, and you can always print the VPN address. You can always print the EC2 instance public IPs. If you are creating a Route 53 DNS, you can always print the values like the DNS record has been, what the DNS record has been created. So there are different output values which are associated. Now output values always going to return a value for the Terraform module with the several uses. A child module can use the output to expose the subset of the resources attributes to a parent module. So you can actually get the values whenever you are going to inherit and run even the child modules. A root module can use output to print the certain values at the CLI output. This gives the user the advantage that every time they apply, they can be sure that the resource has been created within the Terraform and they directly get these values. Now, normally, whenever you are going to execute, your developers and other folks would be interested in these values because these values they are going to use within their code as the endpoint. So whenever your application is executing, it calls the and these endpoints in order to send the request to them. So it makes sense that we put these variables in the output wherever possible, so that Terraform is able to relay all the information to the user. And then when you are using the remote state and remote module, output can be accessed by the other configuration via the Terraform remote state data source. So this is another important thing, that these values can be used within further inside your configuration, and you can store it inside your Terraform remote state data source. So this will provide these for the further use. Now, how do you declare an output variable? So suppose if you created a VPC ID, you can define the output and the resource ID that you wanted to provide, and we put a description and the value. So if you see, here is a generic way of where we are providing the instance IP address, where we are outputting the server private IP. Here we are outputting the VPC ID, which uniquely identifies that VPC. Okay. Now what happens is, here is an actual result what you can see. So if suppose we run Terraform output, it will provide us the URL and the VPC ID and how much server count is there, right? So you can actually define like this. Here is an output for lib URL. You can directly call the ELB output and get the DNS name for it. Similarly, you can actually calculate the length of your EC2 instance ID, and you can accordingly create the servers a web server count from that, right? So this is how you can actually use the variable outputs. Next comes Terraform local variables. Now this is again very important. It allows you to pass the certain values within your Terraform modules when you are going to write it. Now these variables that are local to a module, what this means is that you can only use them inside the module. Now they are actually defined and assigned, used in the same module, and defined as a local block. For example, a snippet on the local block. Now, why you are going to use this local blocks is, suppose you want to pass some variable, a value which might differ within your organization, but that is not directly corresponding, but still it is locally required within the module. So you can actually use the local variables in those cases. Now it can be declared once and used n number of times inside the same module, because you have to remember that local module or local variables are only available inside the module itself, and these can be accessed by the objects by using a format local.variable_name. Now, unlike the variables found in the programming language, Terraform locals don't changes the variable during the Terraform runs, plan, apply, and destroy. This is very important. That what happens is, usually the other variables that you have seen, the input variables, output variables, they can change based on the resources that you are actually creating. But if you are going to define a local variable, then these values are not going to change. These are local to a module, and these are fixed. So it does not matter that if you are creating another resource, these are locally defined inside the configuration for the module to use. So it's going to use them. So it does not change. These are not going to change the values, even if you are applying the different operations like plan, apply, and destroy. You can use the local variables to give a name to the result of any Terraform expression, or reuse that name throughout your configuration. So unlike input variables, locals are not set directly by the users in your configuration. This is important to understand, that usually up till now, the variables that we have discussed, the input variables and output variables, those were mostly controlled. One was controlled by the users, like the input variables. The output variables was actually the Terraform output by applying the changes. What the AWS return the values to us, we were displaying those values inside the outputs, right? But in case of local variables, the users is not having a control over it. Neither the AWS is having the control. What we have defined, it becomes a part of our configuration, which the users cannot directly override. But these variables are used internally. So you can set up the name for the expressions which can be called internally, and this makes your configuration dynamically in those sense. Now, so what is a local value in Terraform? Now you can compare it with the traditional programming language, then it will become more clear to you. So input variables are analogous to function arguments that you pass to a function. Output variables are analogous to function values that the function returns inside the coding. If you if you are aware about the coding, then you should be easily able to relate. You can pass the different values inside your function. It becomes the input variables. The what functions always returns a value. So the value that is being returned, that is called the output values, and the local values are comparable to the function's local temporary symbols that are used inside the function. That is what we call as the local values within the Terraform. Okay. Now, when are you going to use the local values? This becomes important. So local values can be helpful in avoiding the same values or expression multiple times in a configuration. So if you are going to repeat the same values within a configuration, so better that you actually create a local value for that, and then you can use it multiple times inside the module. What this is going to do is this will allow you to actually define a value at the very start point, and then the module is actually the different times you are inheriting those values within your function. So this will allow you, but if you overuse this, they can also make a configuration hard to read by for the future maintainers, and by hiding the actual values used. Now, because you are actually referencing the value which you have initially set, and now if you have a particularly bigger module or the resource, too many resources, and now you are inheriting it again and again inside the function. So, and if you are overriding again after a point in time, then it becomes difficult for the user to understand how that value flow is happening, right? So it might be easier for you, but then if you overdo this local variable, then it might become harder for the other people to understand what value will it be picking up. Now, local values only in used in moderations, in situation where a single value or the result is used in many places, and that value is likely to be changed in future. So only in those cases we are going to use the local values. Okay, and this the ability to easily change the value in the central place is the key advantage. So the key factor here is that suppose when you should use the local values, right? Because you cannot overdo it, it will make it more complex, right? So suppose if a value is getting changed again and again, and we expect that over a period of time the certain value might change, then you will have to identify that value inside your module again and again every time, right? And change it. So suppose if I have to overwrite my module tomorrow, I have to make certain changes. The problem here is that I will have to make a change at the multiple places. But if I define a local value inside my module, then I will only have to update that local value, and it will be changed at multiple places, right? So I don't have to overdo, and I don't have to change it at multiple places. This makes my work easier. So it makes sense that in those cases, I'm actually using the local values. Now, if you look, each local block can have many locals as needed. There can be any number of local blocks within a module, so there is no limit to it. The name given to the items in the local block must be unique throughout the module, and the given value of any expression is valid within the current module only. Now, the expression of a local value can refer to the other locals, but the usual references cycles are not allowed, and that is a local cannot refer to itself or to a variable that refers directly, indirectly back to it. So you have to be pretty much careful that the names and the items that you are using inside the locals, because you can use it multiple times and you can create as many locals as you want, but they all should be unique. And they can you can give a value that can be an expression, so it is valid for your current module only. And the local values can actually refer to the other locals as well. Obviously, you are going to overdo in this case when you are actually referencing one local to another local, and it is then picking up and overriding. So this will make a complex case, but then you can do it, and usual reference cycles in these cases will not be allowed. You can only refer to itself, and the variables that refers to it indirectly will be able to pick those values. So that is how you can, that is all about the variables. and we are going to discuss about the conditioning next, but that we are going to discuss ahead, why you are going to do a certain conditioning, what is depends upon, and so on. That we are going to discuss in our next theoretical session on the Terraform. Now it is important to at least understand this up to a level, because when we are going to do the lab session for Terraform, we will be using all of this. So you have to keep this in mind. You have to understand the different types of variables which are there, and how and when to use which type of variable. This is going to make your Terraform code more readable, and this is going to help you write more generic forms of Terraform module. So that's all for this video. If you have not subscribed to our channel, please do subscribe to our channel, and do let us know if you face any issue, or we will be reverting back to your queries. Thank you, everyone. See you all in next video.